RFxpert is a benchtop scanner that provides accurate and repeatable measurements of near-field and predicted far-field antenna patterns in real time. Single-frequency scans are executed, cataloged, and visualized within a second, not an hour, and an antenna can be completely characterized across its operating range in less than a minute. RFxpert lets you quickly measure the performance of an antenna design with far-field pattern data and radiated power levels. You can also gain immediate insight into the root causes of performance challenges by analyzing the near-field results.
RFxpert has helped to transform the design process for leading telecom, space electronics, computer, automotive electronics, and contract equipment manufacturers.
The RFxpert scanner connects to your workstation via USB and comes with client software to help you analyze, compare, and archive your scan results. The scanner is an array of 384 electronically switched probes. There's no mechanical movement or other hardware required, so scans are quick and repeatable. RFxpert provides complete near-field and far-field characterization between 700 MHz and 6 GHz, with near-field only data as low as 300 MHz. It can also integrate with a network analyzer to measure gain and efficiency, or a base station emulator to test cell phone antennas. To demonstrate the RFxpert system, we've placed a passive antenna on the scanner and powered it with an external signal generator. RFxpert can also be used with multi-antenna configurations and active devices. In the RFxpert client software, we initiate a fixed frequency scan and choose our frequency of interest. We can even run a continuous scan, which allows us to see the effects of design modifications in real time. The first display shows normalized far-field values in a three-dimensional plot, along with two bisections. The bisections are 0 and 90 degrees by default, but are completely user-definable. Each of these charts can be restricted to theta or phi polarizations, giving you a complete picture of the far-field antenna pattern. RFxpert also presents absolute far-field values for radiated power and EIRP levels, as well as efficiency and gain when input power is known. RFxpert computes these far-field patterns based on its near-field measurements. This near-field data can also provide unique insights into design problems by visualizing resonances and surface currents. In this three-dimensional map of magnetic field intensity, the grid below the graph corresponds to the individual measurement points on the surface of the scanner. We can also see two-dimensional plots of the intensity divided into HX and HY polarizations. Rotating the antenna 90 degrees shows the same distribution but with opposite polarization. Phase maps are also available for each polarization, and all polarized amplitude and phase charts can be viewed in 3 dimensions. In addition to providing detailed near-field and far-field data at a single frequency, RFxpert can characterize an antenna across its entire operating range and run any additional tests specific to its device class. With the help of a network analyzer, RFxpert can perform automated swept frequency scans to gather near-field and far-field measurements across a variety of different frequencies. We can characterize our patch antenna by specifying its operating range and the number of spectral steps. When the scan is complete, we can easily compare the near-field and far-field results from various frequencies. And we can see how the antenna performs throughout its operating range by plotting radiated power against frequency. Any weaknesses in the range can then be examined more closely to determine the root cause of the performance problems. Because we used a network analyzer as our signal source, RFxpert can measure the input power information along with the scan results and calculate efficiency and gain, once again automatically plotting them across our operating band. When designing Wi-Fi devices, the parameters of a scan can be set to synchronize with the RF bursts associated with data traffic. When configuring the scan, we can select continuous wave, GSM signal, or even manually specify pulse shapes to measure antenna performance under realistic conditions. Working with the base station emulator, RFxpert can be used to easily characterize a mobile phone by scanning at standard cellular frequencies and power levels. A BSE scan allows us to select channels and scan at various power levels at each channel. RFxpert will ask the BSE to call the phone and automatically run it through the settings. This can be extremely helpful in sample lot and production line testing. With its near-field scanning and far-field prediction, pattern data archiving, and comprehensive comparison features, RFxpert is a powerful tool for quickly assessing the impact of design changes or the addition of other components and packaging right from your bench. This is a scan result from our basic patch antenna. Introducing other elements that will be present in the final design can help us to assess the device's ultimate performance. Here we'll add a small circuit board at the bottom of the antenna. Rescanning shows a significant impact in the far-field pattern, and we can see that EIRP has been substantially reduced. Once we've established a far-field problem, we can examine the near-field data for additional insight. Here we can see the circuit board's effect. We'll modify our design and rescan. This looks much better in the near field now, and checking the far field data shows us that the problem has been resolved. We can easily return to previous scan results to compare them if we need more information about the effects of our modifications. For more precise comparisons, we can use golden sample mode, which subtracts two measurements and graphs any variation. Any two scans of the same type can be quickly compared via drag and drop. Here is the difference between swept frequency scans of two iterations of an antenna design. In addition to viewing the near-field and far-field distribution of the effects of this design change, we can also see the delta in radiated power and EIRP plotted against frequency. In this case, the chart helps us understand that an increase in performance in the low end has come at the cost of compromised performance in the higher frequencies. One limitation of a planar near-field scanner is that only one hemisphere of radiation can be scanned at a time. But if your device can be turned over, RFxpert can stitch the hemispheres together, giving you a complete picture of the antenna pattern. This aggregation also captures the total radiated power, which is reflected in efficiency measurements. RFxpert scans are highly repeatable, and all scans can be archived for later reference. This streamlines comparisons during sample lot testing or when modifying existing designs for cost reduction or component obsolescence purposes. RFxpert also ensures the portability of your characterization data. The client software can be freely distributed within your organization, so you can share your project files with colleagues to get their input and compare results. All graphs can be easily copied as images to aid in communication with colleagues and management, and any dataset, from a single bisection to a complete project file, can be exported to Excel for further analysis or integration into other software tools. RFxpert's real-time scanning capabilities provide significant design advantages throughout the product lifecycle. Having immediate access to far-field data saves time and cost by reducing time spent in chambers. The unique near-field data provides insight into the root cause of problems. This novel antenna pattern measurement system allows for more efficient and cost-effective solutions, project cost containment, and accelerated time to market. RFxpert. Rapidly design and characterize antennas in your own lab environment in real time.